Everybody, thanks for joining us today. My name is Cody Thomas, and we're going to be going over the Mavic 3 Multispectral and the Aeroview platform from Aerobotics. So just to give you guys a lay of the land today, I'm going to give a high-level overview of the aircraft, the Mavic 3 Multispectral, and how it's been used since its release about a year and a half ago. It's been very popular, so we'll get into some of the information about what makes that aircraft very special. Essentially, it's been an incredible piece of technology that growers have been using since it came out. And Brett here will go over the Aerobotics Aeroview platform here just a little bit. So we'll keep you guys here on the call for about an hour. We'll take questions at the end, and I'm going to go over some aircraft specs, how it's been used, the success that customers have seen using it in the field across a number of different verticals. And Brett will go into the Aeroview platform and why that's been such a powerful solution for permanent crop growers across the world. And we'll take questions at the end. So if you can, hold off with your questions until we reach the end of Brett's presentation, and we can get to those questions.
Just in the meantime, sorry as well. Sorry, Cody. Feel free to post in the Q&A section with any questions, and then we can get to them at the end. Thanks, Cody. Sorry.
No, perfect. Yeah, punch them in there, guys. So a little bit of a brief history here in Advexure. Advexure first started in 2012 in Wisconsin. The CEO, Travis Weibel, started off selling DJI equipment back during the early consumer days of DJI. Pretty cool origin story, if you will, selling these products out of a garage. And fast forward to today, Advexure has grown to be one of the largest UAS distributors in North America. We service all 50 states, including Canada and Mexico. So it's been an incredible achievement of Advexure over the past 12 years since its inception. And we service every industry, every state. It's been an incredible experience working with Advexure and seeing the growth of the company. And just to give a bit of a highlight on some of the accolades. So we have over 10,000 products in our portfolio. We're 100% agnostic in terms of UAS platforms that we sell and support. We're partnered with over 100 OEMs, both hardware and software. We haven't gone too far outside of the US in terms of Europe, Africa, Asia. We're pretty dialed in North America. Once again, all 50 states we have customers in, so we're pretty specific to this continent here. We have 19,000 plus service operators that we've served, and over 2,500 public safety agencies currently in our portfolio. The crux of Advexure since its inception was public safety, and as Advexure grew, team members came in from different industries, and we service, once again, all industries. And my personal background's in agriculture, so I spearhead a lot of the agricultural customers that come through. We have SMEs, subject matter experts, located across the country. And even though, yeah, we are a dealer, drone dealer, our product really is knowledge and support and customer service. A little bit about myself here. So I'm from Northern California. My personal background's in rice farming. Began using UAS in agriculture back in the early days, if you will, 2016. In terms of technology, that's a long time. A lot has changed since 2016. I've worked with numerous agribusinesses across the US and do consulting with agribusinesses here domestically and abroad as well, especially on the rice side. I've been a contractor for a utility project back in the early days of when drones were being used in that side type of vertical. So that was an interesting experience. Met a lot of very skilled operators who are now business owners in the utility side, and got hooked up with an operation using drones for security purposes in West Africa. So I spent a bit of time in West Africa doing some oil and gas surveillance stuff and logistics for that particular outfit. I ended up going back to Nigeria separately through contacts I made to consult with the Nigerian government and the Rice Farmers Association of Nigeria back in 2022. I joined Advexure as the VP of Business Development back in December of 2021. And I'm constantly bringing on and onboarding new agricultural customers. And it's an incredible vertical of how drones have been changing the agricultural landscape. And the hot topic right now is, of course, on the spray drone side, but the imagery side is still very large and really evergreen, if you will. So it's been a unique experience servicing growers come out of the woodwork that want the new Mavic 3 multispectral. So just given the Mavic 3 multispectral, the M3M, a bit of an overview here. So it's a 4-band multispectral with one RGB camera. It can operate separately between the cameras, so you can just use the multispectral cameras, or you can use the RGB camera. So depending on your use case, if you want to collect data for land leveling purposes, you can use just the RGB camera, not collect data from the multispectral cameras on board. This has been an incredibly valuable tool for providing important analytics on whether it's production side of agricultural operations or R&D, or if you're using ground or spray rigs for variable rate, it's been a powerful tool for that as well. The most unique thing about the M3M is that there hasn't been anything like it that has hit the market before. You know, there's a number of other multispectral cameras on the market, but those are great, but those are a bit more expensive. They can be a bit more difficult to utilize. You have to use them in tandem with a larger aircraft and so on and so forth. So when the Mavic 3 multispectral came out, it opened up the door to a whole new demographic of customers that can afford it. It's very affordable, that can operate it easily, very low barrier to entry, and it's high quality. So you can get up and going the day of and not worry about a steep learning curve, if you will. So growers have been using this since it came out about 1.5 years ago on their farming operations, large and small, as well as aerial applicators with their spray drones. Ranch managers have been utilizing this, agronomists, PCAs and CCAs, so pest control advisors, crop control advisors, researchers, both in academia and in the private side, have been using this pretty heavily. Environmental scientists and foresters and urban planners also utilize this aircraft as well, because once again, it's easy to use, it's easy to scale internally with these companies, and it is of great quality. The experience has been a very positive thing amongst really everybody that's acquired a Mavic 3 multispectral. And just to give you guys an overview on the multispectral here. So there's 3 Mavic 3 Enterprise drones that make up the Mavic 3 Enterprise systems. There's the Mavic 3 multispectral, obviously. Then there's the Mavic 3 Enterprise and the Mavic 3 Thermal. The Mavic 3 Enterprise is just an RGB camera drone. The Mavic 3 Thermal is RGB and thermal, and of course, the multispectral is RGB with a 4-band multispectral payload. All 3 of these drones are very easy to utilize. They're cost effective. They're great. The Mavic 3 multispectral has around a 40-minute endurance. It really depends on your scope of the field that you're flying. So if you want to fly 400 feet with the 70% overlap, you can get closer to a 40-minute flight time. But on average, typically you can expect anywhere from 32 to about 35 minutes, I'd say. Now, on paper, it has a 19-mile range capability. I would not try that. Don't send it out 19 miles. That's a bit far. You might not get it back. So keep it within visual line of sight if you can. It does have great range. It'll get out there quite a ways. If anything, you'll lose video feed first, but you'll still have good telemetry and control of the aircraft. So distance is something that it can easily accomplish for you guys, but keep it within visual line of sight if you guys can. I would expect for you guys to possibly lose some video feed here and there if you're flying around large trees. You know, the interference from the trees can block some of the video signal coming back to the RC. So if you can, give yourselves a bit of a buffer away from trees, and that'll extend your video telemetry range. 26-mile-per-hour wind resistance, so it can handle some gusts for sure. I would not recommend anybody fly it near that apex of 26 miles an hour. I'd say if it's over 20 miles an hour, I would probably not fly at all. Wait until the following day, or wait until the winds drop below 18 miles an hour. If the vegetation's blowing a bit too hard in the wind, you might get some blur in the imagery, so it's best to fly on calm days. It does have real-time terrain following capabilities, so if you're flying across uneven land, you can utilize that feature to maintain a constant ground sampling distance above the ground. It's also equipped with a 20 megapixel RGB camera, the mechanical shutter, so it's a mapping drone through and through. With the 4-band cameras up on top there and the RGB camera, this is pretty specific to mapping. So this is a great tool if that's what you guys are looking for. The multispectral cameras on board are green, red, red edge, and near infrared. Those are 5 megapixel cameras. So if you need to get higher resolution on your crops, it's best to fly a little bit lower to the vegetation to increase resolution if you need that on the data side. It is great when you're flying in, whether it's some haze or some cloudy environments. It does a great job with the light sensor on top. Obviously, having a calibrated reflectance panel is something that I would highly recommend. So if you have a calibration panel, I'd say that's very important. If you don't have one or need to source one, we have them in stock. DJI does not manufacture these panels, so we have them from a different manufacturer that work well with this aircraft. This aircraft does also come with an RTK module. However, the Mavic 3 Enterprise and the Mavic 3 Thermal do not come with RTK modules standard like the M3M does. So this is a nice feature to have, or a nice tool to utilize when you guys need to do, whether it's variable rates or R&D type projects. Just to go over the multispectral camera specs here. So the near infrared is around 860 nanometers. The red edge is 730. The red 650. The green's 560 nanometers. And once again, the RGB camera is a 20 megapixel mechanical shutter camera. The sunlight sensor. This is very important. This ensures the data is accurate and can be compared across different times and lighting conditions. It compensates for changes in sunlight intensity. It helps ensure that variations in light intensity do not affect the imagery. And once again, just to highlight this, I definitely recommend having a reflectance panel in your arsenal. This will provide a reference for absolute calibration. And it is also a requirement for the aerobotics guys to process this data. So even though you can fly in some adverse weather, not preferred in some adverse weather conditions, you got to understand what the lighting conditions can really mean on the back end for your data processing. The Mavic 3 Multispectral has great endurance, as I mentioned a few minutes ago. It can fly for 35 minutes or so. Really depends on the scope of your flight parameters, how many acres you're flying, and all of that. This is a screenshot from the RC controller here, and this is an example of 100 acres. So 100 acres at 400 feet with 75% overlap, flying at 22 miles an hour. That's a 22-minute flight time, or excuse me, 22-minute mission time. So it's going to take you 22 minutes to fly 100 acres. If you need to drop altitude and fly at 300 feet under the same parameters, 28 minutes. If you drop down to 200 feet under the same parameters, 57 minutes. And once again, at 100 feet, 3 hours, 42 minutes. So that's a big change in flight mission time, depending on what altitude and what flight parameters you guys are going to fly under. So if you guys are trying to understand how long it would take to fly X amount of acres, I would take a screenshot of this and do some simple multiplication, and that should give you a pretty good idea of how long that could probably take you to fly hundreds of acres in a day if needed. So depending on how many acres you guys need to fly, sure, a fixed wing is an option in many cases, but this aircraft is a fantastic tool to use under large acreages as well. One more thing I want to highlight on this is you have a 400-foot and a 300-foot example here, and it's a 6-minute difference. At the end of the day, resolution is your best friend. I would say try and fly a little bit lower in most cases to increase resolution, because it's only going to help your data side and your deliverables for your customer. This aircraft's been wonderful because when you have enough batteries in your case there, you can fly and charge batteries at the same time. And you can chew through 1,000 acres in a day, no problem. I've done it. It does a wonderful job. And the batteries are very reliable. They don't get too hot in the sun. You definitely recommend you guys have at least 3 or 4 extra batteries in your guys' case. So we have partnered with Aerobotics to support the M3M and their Aeroview platform. This bundle includes the M3M, which also comes with an RTK module and an SD card already installed in the drone. Comes with the RC Pro Enterprise Smart Controller. Comes with 1 battery, so obtaining a separate battery kit, which consists of 3 additional batteries, is highly recommended. Comes with props, an RTK module, charger, power cable. All of those accessories come standard with the aircraft. And when it comes to the Aeroview platform, the pricing of that is typically customized based upon your crop type and how many acres you plan on flying. That's something that Brett and myself can work with you guys on. So the M3M has become the preferred aircraft for collecting data for the Aeroview platform, and Brett can highlight some of those success stories and examples as well. And I'll let Brett jump in here and introduce himself and give you guys an overview on the Aeroview platform.
Cool. Thanks, Cody. Thanks for that background. Share my screen quickly. Okay. Can everyone see my screen?
Gotcha.
Cool.
Yep, we can see it.
Cool. Thanks, Cody. Thanks everyone for joining the webinar. I think Cody gave a great background on the capabilities of the drone and the value it can add. Maybe just a bit of background on myself. So my name's Brett Agiotis. I'm the drone operations manager at Aerobotics, and we manage usually we actually service growers. So we get pilots to fly on their behalf and collect the data. Then we process that data and present it back to them. But recently with the launch of the DJI M3M, we saw a huge opportunity for growers actually to fly themselves. These drones are a fraction of the price of other drones and sensors, and you're still getting the high resolution insights from that. So we're also working with expanding this fly your own sort of product to growers across the world. Cool. So I'll just give a quick background of our company and how we came to work with drones. So that should say 2024. We currently have worked with over 1.3 million acres across 18 different countries in the world. We've processed almost 300 million trees to date, and we work with well over 250 growers, packers, and marketers. And our data is essentially used to measure variability in tree growth and performance. And then we help customers to explain and to correct certain limiting factors with their production through different insights like yield, soil variability, pest pressure, etc. Cool. So how it works is essentially, now you can get an M3M through the likes of Advexure, and then you can go and collect the data yourselves and upload that to our platform. So how we essentially work with that data is you will firstly collect the high resolution drone imagery. The drone will follow a flight path, as Cody showed, go along the tree rows, and it will collect thousands of images, either multispectral and visual data or just the visual data. Then once you've collected that, you'll upload that data to our platform. And then we have machine learning algorithms that stitch all that data together. And because of the different bands, we can overlay and give these different insights. So we can give high resolution georeference map layers, meaning each picture has a GPS coordinate attached to it, so we know where that picture was taken. Then how we turn those maps into data is we essentially, through the high resolution visual imagery, this is for perennial crops, fruit and nut trees, we can annotate and draw contour lines around each and every tree in the orchard, and we can assign per tree analytics to that based off the drone data. So through capturing multispectral data, we can give insights such as tree health, tree vigor, canopy area, volume, drainage, etc. So the values, you can see that from a high level overview of your farm, and you can really go more granular to a per tree level, how each tree is performing in the orchard. So that's a per tree metrics. And then we can put this into general zonal information as well. That's aggregating the per tree information into more digestible format per se. So that's if you need to use this for applications like variable rate application, knowing where to apply more or less resources. You can view that data and then practically implement that through crop sprayers or through drones. And then as well, through these high level insights, you can take action in the field with our scouting app, which I'll touch on just now. Cool. So I'll just show the general Aeroview M3M platform features with this bundle. So like I mentioned, firstly, you can get high resolution maps. There's a lot of value in getting high resolution drone data. I think growers can often be quite stuck in the field and, their head sort of in the crops, and a general broader overview, like an aerial perspective, can really open up your eyes into how the farm is performing, the layout, any visible issues you can detect. You can really see a lot of detail just with the high resolution visual imagery like here. And then we can generate these different map layers, like I said. So we can generate elevation or map layers. That's essentially through the drone and the sensors that it uses to create a digital terrain model. And that shows a lot of issues correlating, with irrigation, poor drainage, that sort of stuff. Then, like I said, all the plant metrics are then aggregated into zones where you can show variation across the farms, either in individual blocks or on a whole farm level. Then you can download those performance maps and input them into variable rate application equipment. Then another value add is we can help with tree inventory management. So how well are you utilizing a piece of land? Obviously, growers don't have the time or resources to go and manually inspect or see how many trees in production you have on a piece of land or thousands of acres. So at scale, while we collect the drone data, we can actually annotate, like I said, every single tree. And if there are gaps, we can annotate that as well and put that as a gap or missing tree. So you can then go and rank your orchards according to the most missing trees. You can order that according to different cultivar types, and that can be very useful to, again, show how well you're utilizing a piece of land. But again, that can inform nursery orders. If you need to know how many missing trees do I have for this cultivar type, you can download our table showing the exact number of missing trees, export that, and send it to the nursery to know how many orders you need to take in. Then the tree physical parameters, this is the canopy area. So again, drawing a contour around those trees, we can tell you how big those trees are. It's great to see variation, in different tree canopy areas, and that really can give value with applying less resource in certain areas, saving you time and money with variable rate application. And then tree performance, this again is the per plant metrics for tree health, tree vigor, canopy area, and volume. You can pinpoint on a per tree level if there's underperformance, and also, like I said, the general zonal layers of the trees in an orchard or on a general farm level. So with the platform as well, the value is to use the compare feature. So you can use a split screen. And first, this slide is showing the image on the right is showing a flight we did in November 2021. And the metric here is tree health. So it's showing the tree health of this entire farm. Then the image on the left, December 2022, is when we did a follow-up flight. So the value is sort of doing year-on-year comparisons. With the data, you can pick up any issues and insights and action you need to take. You go into the field and rectify that. And the idea is to see that there's improvement year-on-year or season-on-season with a follow-up drone flight. And you can benchmark that with the scores we give. If the average tree health is 0.35 out of 1, that's pretty low. But then in December 2022, it was 0.45 out of 1. That there's an increase in the score, which can correlate to better yield outputs and tree performance. And then again, this is comparing different layers. So it's not only to look at one certain insight and deduce what you need to do from there, but we allow growers to look at different insights in tandem. So the image on the left is showing tree health, and then also canopy area, the image on the right. You can deduce is a smaller canopy area correlating to lower tree health. If so, we need to maybe focus more resources in those areas. Again, you can use variable rate application. Then also you can actually go into these smaller, poorer performing areas and see this is where the value comes in with the grower. They know the farms very well and see, is it a soil type related issue, drainage, etc. Take those steps to intervene and take action, and then you'll see an improvement again when you do a follow-up flight. So viewing different insights in tandem can really help you to identify the limiting factors at play, to inform what you need to do to improve that. Then it's quite nice. There's a collaboration feature with the platform. So if you see a certain insight in the platform, you can share this with your team. So you can add your farm managers, your agronomists, your PCAs, your scouters, to say, listen, I saw this, we need to take action here. You can send an email of the screenshot or put a comment, and that gets sent directly to them. So a really useful tool if you have a lot of people in the team to chat about different insights you found and just collaborate in general with the insights. Then this speaks to, so once you've, again, if you pick up something, you actually can assign a task. So you can pick a specific tree or area, and like I said before, that's georeference. So you know exactly where that coordinate is. You can assign a task to someone in the field. If you download our scouting app on your mobile phone, you'll get almost like a text alert saying this person has assigned a task to you. Then you can actually go into the field, and that GPS location, it'll guide you to that location. And then again, this is where the value comes. The grower knows the farms very well. So if there's areas of underperformance you've picked up in the drone data, you can go into the field and see and quantify what that is. If it's pest related, or soil type, or there's a burst irrigation pipe, etc. You can actually take photos and notes of that particular area, and then you can sync that when you get back into the office. And this is what it's showing here, to spatially visualize the scout findings. And you can categorize it. If it's an irrigation related finding, pest, disease, or general notes, then if you click on that, I'll show in the next few slides, you can see the picture taken, the comment and context. So quite a nice way to relay that back from seeing the insight, going into the field, taking action, and then seeing over time, has this made an improvement or not? Then the image on the right, that's just another complementary thing we give. So we give free weekly satellite data. So you can get satellite moisture maps, satellite vigor or biomass maps, and visual maps as well. So then the satellite will hover every few days, and you can click on that. So this is also quite a nice way to correlate drone-related findings with satellite data to see if there's a general trend or pattern. So growers find a lot of use in this on kind of a macro kind of level view. And this is nice. This is comes free. So you can draw up a farm on our platform and get this complementary data week on week. So this is speaking to the in-field app, the scouting app that I was speaking about. So if you're in the field, what's quite nice is you can draw up a block ad hoc if you want to go and scout and see what the issue is. But what's also nice is you can view the map layers in the app. So if you've flown, uploaded the data, and you've seen the drone data on your computer, you can also download this drone data on your phone to the scouting app, and you don't need internet connection. Then when you're in the field, it actually guides you where these markers are, or these locations. You can go to these poor performing zones, the lighter green sort of color, and then go and see, are there any physical or evident things that are showing there's underperformance here. And again, this is the value, this person here, it was a pest related finding. He tagged that there were 20 banana spotting bugs found here in this area, correlating with the poor performance. You can log that, and again, that relays to the platform. So quite a nice end-to-end way to pick up the issue, rectify it, and then see over time if there's been a difference made. So I'll just show also a few practical insights with the perennial crops. So we essentially try help farmers firstly to understand what are their current challenges in optimizing their production, and all these different factors, but it often correlates to crop health, irrigation issues, nutrition, crop protection, and crop inventory management, some key factors for optimum production. So this is a practical example of I think this is a citrus orchard. What we can do is this is showing tree health, so NDRE. This measure is the plant's ability to absorb red light and to photosynthesize, create sugars, and grow. And it's the chlorophyll content, so its ability to grow, essentially. This is fixed on a score, so you can see this chart on the bottom here saying health NDRE between 0 and 1. So that's from the drone data. Essentially, if it's health stressed, the tree, or it's poor performing, it has a low health score, low chlorophyll content, and that's visualized in red or dark orange. Then the higher the score, the higher the chlorophyll content, it's more of a green or darker green color, better performing. So what this screenshot is showing is a particular block. On the left, it's showing the performance, the per tree performance of that entire block, the health category breakdown. But if you want to focus your efforts particularly on areas of underperformance, the image on the right, you can see the histogram. We've actually isolated those histogram bars to the lowest scores, the lowest performing trees. And you can see that particular side is where, of that orchard, the left side is where the most health stressed trees are. So again, we're not saying exactly what's wrong with those trees. There could be a lot of factors at play, but this is the value of using the different features in tandem and actually going to the field and investigating to see what the issue is. Then this is relaying. So this person assigned a scout route, a task, like I showed before. They selected these 6 different scout locations. The person assigned the task, then they actually went into the field and found it was a pest-related issue. So they took photos here, and this is showing the extent of that. The fruit were discolored, the leaves as well. And that had a direct correlation to the insights we provided. These trees are underperforming. So from that, it informed we need to do a spray on these particular areas. The other side of the orchard is fine. And to sort of rectify that before it's too late. It's quite a value add here is the drone insights can pick up things that aren't necessarily visible to the human eye until there's proper deterioration and it's too late for the tree. So this is a great way to preempt this, before the damage is done to the trees. Then this is another example. So this is showing the underperformance with the health again. So these areas in a yellow and orange were categorized in a low health score. The growers actually went there and they found that there was brown rot and alternaria spot. Yeah. So physical disease and pest damage caused. So they could determine these particular areas of concern, and they concerted efforts or focused efforts to those particular areas to rectify that. Then this is NDVI. NDVI is the vigor, so how vigorous the plant is, or the biomass of the plant. Again, it's fixed from 0 to 1. If it's closer to 0, it's a light green color. It's got a low vigor or biomass, and then the darker green the color, the higher the vigor or the biomass is. And this is just an example showing this area with a very high vigor. There was actually a burst irrigation pipe they found. So there was too much water flowing to this particular part of the orchard, and it was fine then, but over time it would become detrimental and a problem if these trees or zone of trees were getting overwatered consistently. Then this is just speaking to the inventory management feature we have. So just showing here the trees in blue are annotated as trees in production, living trees. Then these black dots here are the missing trees, the gaps. So what's nice is if you have a lot of acreage and you want to know exactly how many trees you have in production, we can give you an exact count of that. You fly, like Cody said, it takes you less than a day to fly 100 acres. You upload that, we process it within a few days, and then you have an exact idea of your tree inventory. And then again, on the left, you can rank this according to the blocks with the most missing trees, and you can classify that according to cultivar type, etc. It's really useful having that instead of trying to rely on pen and paper and counting how many trees you have. There's a lot of room for error, obviously, with that. So this is a much cheaper intervention to do at scale, and it's a lot quicker and more accurate. This is the pest and disease monitoring. This is another product we sort of have. It ties in with the in-field scouting app. So what's nice is you can monitor pest pressure over time. So the first, you can do pest monitoring. So you can set up whatever traps you want. You know, if you have a fruit fly trap, or if you have a bollworm trap or something like that, any traps you want, you can add that to the Aeroview platform. And then week on week, you can log your scouting data, you know, how many pests you found each week. You can set a threshold here. So if you see Dave set a threshold, I think, of 4, you can see in week 6, they found 6 of this fruit fly, which exceeded the threshold. And you can see that in the platform in real time once that data is synced. So quite a nice way to track pest pressure over time instead of, you know, relying on pen and paper. And this correlates quite nicely as well to the drone data. You know, if you see areas that are underperforming, it could well correlate to pest pressure. So the data ties in together quite a lot, and you can reference that. Yeah, so then week on week, you can easily monitor your pest pressure. Image 2 here, you can count how many you have and save that. It then populates in the platform, and you can also manage pest traps over time to see different traps, how they're doing, what are the thresholds, where the problem areas, and pull a lot of data just from inputting that. And then again, these geo-referenced pest traps and in-field findings are in the platform. You can view that in tandem with the drone data as well. This is just a practical example of variable rate application, a case study. So once we've collected the drone data, like I said, we can aggregate that into zonal levels. And now you can input in particular zones, how much resource do you want to apply? So zone 1 maybe have a higher NDRE score, health score. So you'll allocate only 55 pounds per acre for that. Zone 2 is lower in health, so maybe apply a bit more resource there. And what we found is growers over time save a lot of resource, time, and money with variably applying this instead of blanket spraying. So fertilizer cost has gone up recently, and it's a real pain point we found for a lot of growers. So, you know, having informed data to make those decisions is crucial, so they know how much resource they should apply in certain areas. So this is an example, a post-harvest application in 2019 and 2020. They applied about 84,000 pounds of fertilizer, but then through variable rate application, they actually decreased that to 82,000. So they saved about 1,500 pounds of resource. Convert that, you know, into dollars, it really makes a difference. Then again, during bud break, they cut down, saved another 2,600 pounds. Then their post-harvest in 2021, they dramatically dropped the conventional application because they realized that they didn't need as much resource as they did. So that saved about 70,000 pounds of resource. So in total, about £250,000 they've saved. In dollars, that correlates to millions of dollars saved, just through having, you know, a bit of data and making better informed decisions of what you need to apply. And then what was quite nice as well, they correlated performance with this. So through the variable rate application, they picked up the image on the right, a flight in January 2021. The average health score was 0.49, which is not bad, but a bit low. The variation was 15%. So how the best performing tree differs from the worst performing tree, which was pretty high in that orchard. The image on the left is a follow-up flight the following year in January. The average health score was 0.53, which increased, and the variation dropped by almost half to 8%. So through doing that variable rate application, they were able to correct a lot of this variance and underperformance, and tangibly see an improvement with the performance and the yield output with that orchard. And then this is just showing the canopy area. So the image on the right, there's a very high variation of 37% between the biggest trees and smallest trees. average canopy area was about 1.59 cubic feet, and now the image on the left is showing January 2022, a follow-up flight. The variation dropped down significantly to only 8%, and the canopy area shot up quite a bit to 1.72. And you can see visually here as well, the level of smaller trees decrease significantly, and there's a lot more uniform trees in this block. And again, that is a great output for your yield and general tree performance to get it more uniform. And you can, what's nice, you can pick your preferred metric to do variable rate applications. So if you want to do it based off canopy area or tree vigor, tree health, you can choose, or volume, you can choose what metric you want to use, and then output that into the variable rate application. And it's we've done trials, and it's compatible with Red Ant and Trimble. But if you have any questions or would like to learn more, feel free to reach out. And then happy to share this afterwards. We were featured with Advexure in a DJI case study on a vineyard. So I'll share the link to this video if you want to check out showing the practical application of this platform. Great. Well, thank you very much. We'll open to any questions people may have. The contact, so on the left, if it's anything drone related or sales, please get in contact with Cody. And then if it's anything to do with the platform and the software, feel free to reach out to me. We will share these details after the presentation, and this is recorded if anyone wasn't able to attend. Great. Cody, should we open up some questions?
Yeah, that was great, Brett. Yeah, let's give these guys a minute. And from my personal experience, I mean, there's so many features for the Aeroview platform. Variable rate was huge with a number of my customers in the past. Using the satellite feature with the moisture map was incredibly helpful on mature orchards. If there are smaller trees newly planted, smaller orchards, it's hard to get moisture readings from satellite, which is where the drone can come in and get those metrics on young trees. So getting a handle on young trees that are, whether they're second leaf, third leaf, fourth leaf, I mean, it's great. It's an ideal use case for a drone to start getting those metrics. Canopy size, volumetric stuff, I mean, that's fantastic as well, because that gives some pretty in-depth insights into how those trees are doing in certain soil regions out there too. So once again, coming back to variable rate, treating those zones at the end of the year was helpful to many growers. So definitely encourage everybody to give this a whirl. We do have a chance to provide you guys with some free acreage to run through Aerobotics. So if you guys are interested, please contact myself or Brett, and we can get that taken care of for you. So would love to hear any questions you guys have.
Cool. So I think one here, Cody, if you want to take that.
Sure. How would it look if it was an RGB only, especially at 100 feet? Can the M3M fly faster than? So yeah, that's a good question. So the Mavic 3 Multispectral, this is a DJI kind of a governor on the speed, if you will. And once you drop it down to 100 feet, they limit you on the speed of the aircraft. You can't fly any faster, unfortunately. So you'll have to bite the bullet and fly at that speed that they kind of limit you at those lower altitudes. So even with it being RGB only, it's still going to slow you down, as well. So we can definitely speak offline, and we can kind of come to a conclusion of maybe a proper altitude for you, Pavel, that can help you chew through a bunch of acreages, if that helps.
Yeah, perfect. Any other questions?
Perfect. Well, thanks everybody for joining in. It was great. And thank you, Brett. And our contact information will be shared with you guys. Don't hesitate to reach out.
Yeah, perfect. Thanks very much, everyone, for attending. We will send the link to the recording once it's up. And if you have any questions, like Cody said, feel free to reach out to us. Oh, there's one question. What GSD do you recommend? For tree inventory. So I mean the parameters Cody gave is sufficient. So you can fly it around 400 feet flight speed. What was the flight speed again? Sorry, Cody.
Let me pull it up 1 second. At 100 feet, 8 miles an hour. That's pretty slow.
Yeah.
Severely limited.
And then the 400 feet?
400 feet, 22 miles an hour.
Cool. Yeah, so that is sufficient for us to do the tree inventory. The GSD, I think you'd get off the visual imagery is about 3 to 5 centimeters per pixel, which is pretty high resolution. So that's sufficient for us. We can pick up the trees and actually do the annotations. Yeah, so the optimal height I'd say is 400 feet. You can, but if you want high resolution data, then you can drop to 300 or lower. But like Cody says, you'll then capture a lot more data. It'll take you a lot more time. You upload a lot more. So it depends on your requirements, but we can share this. We have a list of recommended parameters, but in general, around about 400 feet is sufficient to get the high resolution data that we showed.
I've got another question here from Alex. Is there ever going to be a stand count feature? So yes, there is tree counting capabilities within Aeroview. If you're referring to row crops, Brett, maybe you can give some insight into where you guys stand with row crops.
Yeah, so row crops, so perennial crops is our main focus. So it's a bit limited with the level of insight we can give with row crops. Perennial trees, we can give, like I said, the per tree data. Row crops, we can give the general stitch map layers, and with some crop types, some of the zonal insights. But besides that, we can't give too much more per sort of plant insights. It's just very difficult to annotate or pick up each of those plants. So there's still value with row crops, but the level of granularity is a bit limited compared to perennial crops.
What's an optimal flying height for the M3M? So that depends on trees, like the height of your trees, essentially, or your crop type, their plant size. So depending on what GSD you're looking for, that's going to depend on the vegetation that you're flying. So a mature orchard, you can get away with flying higher. If you're talking about newly planted trees or row crops, you'll want to drop altitude. Is your AI using morphology or visual data to determine individual trees?
So it's using the visual data, and from that we draw the contours around the trees, and we have an AI model that will accurately say this is the canopy area of that particular tree. So pretty crucial that we get high resolution visual imagery in order to do that. So we have an AI model that automatically draws those contour lines, but then we have a team of data experts who inspect those contours and make sure that they've been annotated correctly. And maybe if the annotations are a bit too small around those trees, they can adjust and make those a bit bigger to fit the circle, like hug the tree. So it's more accurate.
And how do you separate individual trees in closed canopy orchards?
How do you separate individual trees, closed canopy orchards? Closed canopy orchards. So I mean, if we have, like particular crop types like apples, let's say, or closed canopy areas, it is more difficult to annotate those or give the per plant insights. But there we rely on the tree and row spacing. So we ask the grower for that, and before we proceed to process the data, and then we see what the model can do. If it can pick up those individual trees, if they are sort of separable, then we can. But otherwise, we rely on the tree and row spacing. So we know that this tree is 2 feet apart, or whatever it is. And then we draw a polyline tool on that particular row and draw the contours according to the planting pattern. So if it's not very clear, then we rely on that quite a lot. Cool. What is the
What's the
best
best?
program for conning plants? So
Yeah,
I mean,
I'd
yeah, okay, go
Yeah, I
first.
mean, there's a couple of options out there that are kind of more centric around row crops. I think I would need a little bit more information on what crops you're looking at and their growth stage. But I mean, if they're newly planted tomatoes, for example, you'd want to wait a little bit for them to mature and increase their own little canopy size so that the data, if you're capturing it from a drone, can be more easily ingested from specific software that they can more accurately identify newly transplanted plants and that they are counting the plants and not weeds, if you will. So more than happy to have a discussion with you on the side if you want on some of that stuff. There are some options. So more than happy to point in the direction of one of those. Vigor, how do you calculate that, Brett?
Yeah, good question. I can't remember offhand specifically, but it's something to do obviously with the bands that the DJI drone uses to capture the data. It'll be something like near infrared band minus infrared band, and that's how we get the vigor and also the health. So I can't remember offhand what particular bands in the equation, but essentially it's like adding this band or I'm subtracting that band, and that's how we get the light reflectance or the score of the vigor or the tree health. But happy to send you a mail as well with the exact calculations for the different insights if you need.
Yeah, Vigor is essentially NDVI on the Aeroview platform. So Vigor and DVI, that's essentially the same thing. So measuring the greenness of the vegetation
Yeah.
in this. Right? So yeah, more than happy to send you some info, Pavel. Another question here. I will do the topic about identification tree species in tropical forests. Do you have any suggestion for me in applying this for my project? Brett, I assume you guys don't do anything with the kind of random tree spacing, forestry, for example, right?
Yeah, so forestry is tricky because it's difficult to discern what is one tree and what's the other, because with forestry they have a lot of overlapping branches or pines, so you think this is one tree, but actually that's two different trees overlapping or vice versa. So it's been tricky for us to give accurate annotations on forestry. So it is quite limited. So I'd say with tree counts or tree identification, in general, forestry is quite a challenge to do accurately and to do at scale.
Yeah, I've been asked that in the past as well. In some cases, depending on the tree species, that could be a LiDAR plus RGB application. It all really kind
Yeah.
of depends, but it's kind of a deep rabbit hole. But yeah, I think there's only, from what I know of, a couple of options out there, and I'm not really sure how accurate they really are. And that's a tough one.
Yeah, I mean, there's some platforms that you can use AI, so you annotate a few trees and then you teach the model to do that at scale. But then it's open to inaccuracies in that. So happy also to pass on a few suggestions out there to use, but quite a tricky thing to get right for sure.
Well, it looks like that's all the questions. Thank you, everybody. Appreciate everyone tuning in, and feel free to reach out to Brett or myself if you have any questions.
There's one more question. Based on plant health, are there any indicators, or could you teach it to identify problems like HLB? So I mean, yeah, great question. Citrus greening is a huge problem, especially in Florida. We've picked up. So like I said, we can't necessarily say exactly what is wrong with the tree. There's so many factors at play, but disease detection we get asked that very often. It's a very tricky thing to try and automate and get AI to teach. So what we can do at the moment is show the actual tree performance. If it has low performance or low canopy area or indicators like that, that can quite often point you to it. It could well be an issue with pest or disease. But AI at the moment is quite limited. So I think to detect a disease is still a few years to come. But actually picking up what's wrong with the tree, drone data can play a huge role in that. Cool. Cool. I think that's all. Yeah. Thank you again, everyone, for joining. Yeah. And if you have any further questions, feel free to send us a mail with the contact info, and we'll get in touch.
Thanks,
Perfect.
everybody.
Thanks, guys.